Welcome back. We've been learning about what makes data normal. We've talked about how normal data, right here, is when our mean equals our median equals the mode, meaning that all three of these measures are the same. And then our most popular question has been, well, what if they're close, but they're not exactly the same? And the answer that we learned last class was if the mean, and that's usually represented by x with the bar on top, the median and the mode are less than one standard deviation apart, it's considered normal. And we can now add to that definition. Not only is it considered normal if those three measures are less than one standard deviation apart, but we actually have something called a normal range, and we use the mean and the standard deviation to determine what the normal range is. So the normal range is the mean plus or minus the standard deviation. Quick reminder, this means mean. This little symbol, the circle with the hat on top, that's a lowercase sigma. That's just a Greek letter. It's actually the Greek letter S. And that's the standard deviation for a population. The usual lowercase s stands for the standard deviation for a sample. The only difference between these two is that the standard deviation for a sample corrects for the fact that you don't have all of the data for the population. So it gives you actually a bigger number for this standard deviation, which leads to a bigger range. Either way, the formula for finding the normal range is the same. So the normal range is two numbers. One number will be below the mean by exactly one standard deviation, and the other number will be above the mean by exactly one standard deviation. So you find the normal range by taking the mean, subtracting one standard deviation from it, that's your lower end, and then taking the mean and adding one standard deviation to it. That's the upper end, and that gives you the normal range. So here's an example of when it might be used. The normal range is used a lot in science and in medicine. So a doctor would look at, for instance, what a normal height is, what a normal blood pressure range is, what a normal sugar level is. They use this to figure out where most people's levels should be and what's healthy. So here's an example. A baby weighs a little less than the average weight. So how can a doctor tell if it's a normal weight? So the doctor would take the mean for that age baby and the standard deviation, which is the expected difference from the average, and find this normal range, because 2/3, actually a little more than 2/3 of all babies will weigh either one standard deviation below up to one standard deviation above the mean, and that is the normal range. So as long as the baby's weight is between those two numbers, it would be a normal weight. So in the instance of newborns, here's the information we have. The average weight of a newborn is 7.5 pounds. There's a standard deviation of 2.5 pounds, meaning we would expect a weight to differ by about 2.5 pounds. So the normal range for a baby's weight, on the low end, we're going to take 7.5 and subtract 2.5. So if we do that, we end up with 5.0. And then we're going to do something very similar, but instead of subtracting, we're going to add that extra standard deviation. So 7.5 plus 2.5, that gives you 10.0. So a normal range for the weight of newborns is between 5 to 10 pounds. Anything within that range is considered normal. So quick recap, key points. The normal range, in order to find it, you need the mean and you need a standard deviation, either the standard deviation for the population or for a sample. And the normal range gives you what 68% of data values in a data set will be within. So that's more than 2/3 of all of the data values in a data set would be within this normal range. So that's a lot. That only leaves 32% of your data that's either going to be above or below this particular range. All right, so let's try 2 examples here. Is an NBA player with a height of 6 feet 3 inches considered normal? So obviously, for the height of civilians, those of us who don't play in the NBA, 6 feet 3 would be quite high above normal. 5'7" is actually the average height of men in the US. But in the NBA, the average height is 6 feet 7 inches. And there's a standard deviation of 3.5 inches. So first, we're going to find the normal range, and then we're going to answer that question of whether this particular NBA player has a normal height for the NBA. All right, so our normal range, we've got 6 feet 7 inches as our mean. We need to find the low end by subtracting 3.5 inches. Now I'm going to be careful here. I'm actually going to move my 3. I'm talking about inches, not feet. I don't want to accidentally subtract feet and say that an NBA player could be 3 feet tall. So 3.5 inches. All right. So clearly they're still going to be 6 feet tall. That leaves us at 6 feet 4.5 inches. That's the low end of my normal range. I'm going to do almost the same thing, but this time I'm adding 3.5 inches. That gives me 6 feet 10.5 inches. It's getting very close to 7 feet there. All right, so our normal range is from 6 feet 4.5 inches to 6 feet 10.5 inches. So this NBA player had a height of 6 feet 3 inches. He's actually below the normal. So he's below the low end of the normal range. So to answer this question, is an NBA player with a height of 6 feet 3 inches considered normal? The answer would be no. All right, let's try this other one. I'm thinking about going to med school after college. Is my GPA of 3.25 within the normal range? Okay, so if your GPA were within the normal range, then you, along with the other 68% of applicants, would be grouped together in what's considered normal. So let's see what we got. We have the mean of 3.56 and a standard deviation of 0.34. So we need to find the low end and the high end of the normal range and then to determine if this falls within it. All right, so I'm going to take 3.56 and subtract 0.34. So 3.22. And then the high end would be 3.56 plus 0.34. That's 3.9. So the normal range would be 3.22 to 3.9. And sure enough, 3.25 falls right in between those numbers. It would be in here. So is this GPA within the normal range? The answer would be yes. All right, so that's what today's practice is going to look like. You'll be finding the normal range and determining if values fall within it.